This is a practical problem here on costs, and you've developed a matrix. When you start developing matrices in business, you realize it's just a table, but somewhere along the line the labels got lost, and if you don't keep it straight, which column, what the columns and the rows mean, you can actually come up with very wrong answers. But they're not written down anywhere, you have to know them. Okay, so when you look at the matrix, what I mean is there's no heading here that tells you what is in each row or column. So if I look back through this and I have to figure it out, this column, or this row, I'm sorry, gives the chemicals, right? And the next one looks like it gives the hanger cost. And the next one is plastic. So this column right here is for the suits. The next one is for the shirts. And the third one is for hats. And that's basically all you have to do there. On 13, we're going to say all the costs increased by 5% and write the matrix to represent the increase in costs. Now when you do if you want every single item in the matrix to be multiplied by the same number, that's called scalar multiplication. And you could do it, let's say this is the old cost, so I'll say O for old. You could find the new cost matrix by multiplying the old cost matrix by, you better multiply it by a decimal instead of 5, otherwise we go up 500%, times that old one, and then add to the old one. That would give you a new cost matrix. If you just do this much, you got the change in cost. You didn't get the whole new cost matrix. You could do this in one step though, since you have to multiply anyway, by multiplying by 1.05 times the old cost matrix. So as you multiply this by 1.05, you would get the new cost matrix. Now in this case, not all the costs change by the same amount. Here all the chemicals are going to increase by 10%, all hangers decrease by 5%, and the plastic is going to stay the same. So if I multiply by 0.1 or 1.1, that's going to change everything. When I want to change it row by row, I multiply by a diagonal matrix. I have to pre-multiply by it. And I want the chemicals to go up 10%, the first row to go up 10%, I multiply by 1.10 here. And this will change only the first row. The second one, I need a decrease, so it's the second row, 5% decrease, and the third row stays the same. And then I put the matrix, this matrix goes here. When I multiply by that, then all the chemicals, everything in row 1 will increase by 10%, everything in row 2, which is the hangers, will decrease by 5%, and in the last row all the plastic costs will stay the same. These problems get a little tricky. If you took that initial matrix, your cost matrix, and you multiplied afterwards, post-multiply, oh that's 10, I'm sorry, like this, you would find that all of the suits would change by 10%, go up by 10%. All of the shirts costs would drop by 5%, and all of the what else was there, hats would stay the same. So it does make a big difference whether you multiply first or second by this diagonal matrix. But it's the use of the diagonal matrix that lets you change selective rows or selective columns.